Okay, we're going to run through the VFR Navigation Log briefly. We're going to plot a course. I think this is get my plotter out there. We want to go from Ava Martin Memorial to Salem. So we draw a line directly between the two. We use a nice steady hard pencil there, draw a nice bright line, trying not to tear the paper. And of course, what's the shortest distance between 2 points? Straight line, so we try to do that as best as possible, as long as it's not an airspace issue. And there's really, is Magenta Airport, we're going from uncontrolled airports. The only airspace I see in this area would be this Lindbergh MOA. And to find out about that, we go to the chart, find out what time that's operating. And we find out that, in fact, it is not in operation on this particular day, so that's not an issue. But we would want to check to see if it's going to be hot. In other words, there's going to be a lot of military aircraft in there. That would be something to consider. But you really can't get there unless you fly through it somewhere, so you just want to be aware. Now, so we find the distance. We start out with the distance. Well, first we can write down the fact that we are traveling from, we write down the aircraft number notes. We're traveling from Ava Martin and we won't tell them. We want to have some checkpoints in between there, so we'll wait on that. So next thing we need to know is what is the, we're not going to use VORs, we're just going to use VFR pilotage and dead reckoning, so we're not going to use the VOR. We could write down here some information about the airport. The CTAF frequency, which we'd want to let everybody know we're flying, is going to be 122.7, so CTAF 122.7, because when we get in the airplane, we don't want to have to look at the chart. We want to have it all written down ahead of time. So this is I think that's AOV. AOV is the airport identifier. And we're going to Salem, which is K33. K33. And the frequency there, we can see it right there, 122.9. With a little C in a magenta, again, that means it is the frequency we'd call to let other aircraft in the area know we're coming. That is also the multicom frequency, interestingly enough. Is there a weather station here? No, there's no weather frequency to find out what the weather is. We'd have to call. Here, nope, there's no weather up there at Salem either. So a lot of this information is not there. We would put a field elevation. We'd want to know how high the airport was. So 131 feet. And this one here is 1214 up in the mountains. So we're going to climb almost 1,000 feet to get from here to there. Not to mention we're going to be flying, but I mean the surface elevation is 1,000 feet higher here than it is there. 3,000 foot runway, lighted. So a lot of information we can find here. If we want more information about the airports, though, we look up in the chart supplement US. Okay, so carry on. Looking at the chart, we want to say, okay, we just blast off of that heading. We can be Charles Lindbergh and fly across the Atlantic Ocean without any checkpoints because there's nothing to see. Or, hey, let's maybe, sure would be bad if we were sort of heading over this way towards this controlled airport, ended up landing at the wrong airport. Runways look a little bit similar. Or a little bit similar. Yeah, look, they're aimed the same way, northwest. Aimed that way, and these are runways that way. You could land there accidentally. Whoa, you'd be in trouble because you're supposed to get clearance to land there. Fort Leonard. Looks like there's some military airspace around here as well. So anyway, we want some checkpoints just to verify that we're on course. That might be a tough little road. It's a tiny, oh, wait a minute, this one is pretty big, a highway. Interstate 80. Okay, so that'll be our first checkpoint. When we fly over Interstate 80, that's our first checkpoint. Okay, so how far is, okay, I'm gonna write down I-80. how far is I-80? So start with this 1, with the 0, rather, make sure it's not the beginning of the ruler here. It's 0, and that's 11, 12, 13 miles. Yeah, about 13 miles. 13 miles. So that goes all the way over here under leg, 13 miles. So 13 miles to get to that fix, that first fix. Right, and then we pick another one out here. Well, that you can't see that. That's just a chart thing. Man, there's not much out here. That's too close. There's an airport here, Houston. That might work. In fact, that's not a bad one there, because we can look out the window. Oh, there it is over there. Houston is a little town. There's a road that goes through it, going that way. So that's a good one. Okay, Houston. Or if you're from Georgia, Houston. How far is that? That's 26, 25, 26, almost 27, 26 and a half miles. We'll say 26. Say 26 miles to there. And from there, it's another 24 miles. 24 miles to the destination. 24 miles, and our destination, it was K33. Let me double check that. 24 miles, yep. 24 miles, right? The total distance, just to verify my numbers, is 64. 64 is a total. And that would go, by the way, up in here. It theoretically should go 64. That's the total legs remaining. When we take off, we have 64 miles to go. So we end up with 51 miles to go once we get to I-80. And subtract 6 from, let's see, 4, 5, and that's 4, so it's 25 miles to go when we get there. And, look at that, 24, so you subtract 24 and 25, we should have 1 mile to go here. The only reason for that is because I miscalculated the estimating the actual marking. But that's not bad. If we're within 1 mile, we're doing great. So that's the checkpoints, that's the VFR checkpoints to verify. If we fly along in here, and we end up over the top of an airport over here, we say, hey man, I'm a little off course. There's more wind than I thought coming from up this way. So I need to correct to get back on course. Or if I'm, over this way a little bit too much and this airport's way over there, that's not good. I need to correct going this way. But what is the initial heading? We haven't figured that out, have we? What's the true course? This is the course line. That's the course line. That's what we want to fly, but we have magnetic variation. We also have the wind. So let's look on the actual true first. So if you recall how to do that, we just lay it down here, find there it is right here. There's a line, good, clear line with no distracting printing nearby. So make sure this is lined up parallel to the actual course. It doesn't have to actually go all the way to the end, but you just have to make sure that this is right smack over the latitude, longitude lines. Whoops. You can go either one, latitudes or longitudes, but we're going to use this one here. And so we go up here, and there's the line, goes right there. Okay. So it could be 232. There's 230, 235, 232, 233, but 233 degrees doesn't make any sense. That's that away. So it's got to be the reciprocal, which would be 51, 2, 3, 4, 53 would be 53 degrees. So that's our course. The route, 53 degrees. Or, right. So now we got to figure out what the winds are. Well, the winds aloft, that's a forecast, right? So we go to forecast. You can either ask Flight Service Station or look it up yourself. We're heading towards the east, so we need even plus 500 feet for a VFR cruising altitude. So we look here and we go, oh, look, at 6,000 feet, we'll have a little bit of a tailwind. So we look at the number, there it is, 206. 2006, that's the true wind direction is 200 degrees at 6 knots. So we can transpose that right over here. Wind direction, 200 degrees at 6 knots. It also gives us the temperature, 3 degrees. We could use that for performance. I'll just write it there. We probably won't use it. Now, since it's a straight line, we only have to calculate this once. The magnetic, or the wind correction angle. And we go to this machine over here. I think we have everything we need. I forgot to put 6,500 feet. That's our cruising altitude. Okay, so we turn the thing on. Now you could do a wind triangle here and find the same information out. It's okay. But and you could take that to the written test if you're too cheap to buy a calculator. But we've got a calculator here. So we're going to figure out, just press the, have I got it where you can read it? No, I've got to be careful. Okay, so it says the heading, ground speed, pressure, altitude, etc. We press that button and it asks you wind direction. What's the wind direction? What did I say? 200 degrees, okay? So enter, 200 degrees. Then it'll ask you how much wind? 6 knots. There's 6 knots starting there. Then it's going to ask you what's your course? Well, we said it was 53 degrees, right? So 53 is our course. What's our true airspeed? Oh, I forgot to mention that, but true airspeed was going to be 90. We found that out from the performance charts in our pilot operating handbook. And that can vary depending on how fast you want to get there, right? You can add power and burn more gas and go a little bit faster, or you can pull the power back a little bit and maybe end up with more fuel than normally, but you'd be going slower. So you pick whatever the true airspeed is, but for the purposes of the question, I'm just going to say it's 90. Okay, so you put 90 in there, and then you enter it, and then it says, wind correction angle, 2. So over here, we have wind correction angle of 2. Now we use a little bit of logic. If the wind is a little bit off to our to the south at 200 degrees, it would be a +2. So we have to add 2. That would give us a true course of 55 degrees, right? 53 plus 2 is 55. So that gives us a true course. We made the wind correction angle first. But still, the winds are true. The course is true. Now we got to figure out how to correct for all the magnetic issues. The fact that the magnetic North Pole is not the same place as the true geographic North Pole. So we have to go back to the chart. Let's see, where's our route? Here's our route here. Do you see any magnetic variation lines here? The closest one I see, oh, here's one right here. There it is, magenta. And we go to the top or the bottom, doesn't matter. And we'll go to the top, it's right here, and it's almost cut off there. But it says 1 degree east. Okay, so 1 degree. Now we got to figure out whether to subtract it or add it. Now it does tell you right there. It says east is minus, so it's a minus. So subtract 1 from 55 and you get 54. That gives us our true heading. Now we need to find out magnetic heading. The next step would be the deviation card. And where is it? Here we go. Here's my deviation card. I just made this up. Remember, it's by the compass, and it will be laid out. If you want to fly 90 degrees, you gotta turn to 92 degrees, so you have to add the 2 degrees. There's some kind of magnetic interference with the airplane that requires you to fly 92 degrees. So you have to fly 2 degrees more. Then you pick whichever was closest. Where there might be a 360 here. Might be a 360 here. It would say fly 360. In which case, since 52 is sort of halfway between 90 and 360, you might only want to add 1 degree. At halfway, it was halfway. So, and it's plus. So now you're back up to 55. That gives you the compass heading. You get in the airplane, you take off, you turn, so the compass is reading 55 degrees, and that will take care of the magnetic variation. It will take care of the wind correction angle, all of the necessary things. And you notice, by the way, it's only 3 degrees off, or 2 degrees off, right? 53 to 55, so there's pretty much a tailwind. So that's another thing you can read right in here is ground speed. It tells you 95. So you got about a 5-knot actual tailwind. And ground speed, here it is right here. Let's see, make sure you can see it here. Ground speed right there. Estimated ground speed, 55. Not 55, I'm sorry, that's heading. That would be a trick, wouldn't it? 95. That'd be pretty sad if you were only going 55. You might as well drive. This is a road, by the way. All right, so the ground speed is 95. We got true airspeed of 90. We have effectively about a 5-knot tailwind, which makes sense. So now, and you see there's 2 columns here, estimated and actual. Actual, once you get in the airplane and you write down the time when you arrive over the fix. So we write down what time we left the ground, and then when we arrive over the first fix, we write that time here. But what do we think it would be? How long do you think it would take to travel 13 miles if we were traveling at 95 knots? 13 nautical miles, how long would it take to travel 13 nautical miles if you were flying at 95, right? So how do we get the flight times? We take the distance divided by the ground speed. So, okay. So let's see, make sure you can read this. We go to the calculator function, which is somewhere here. 13, nope, that's not going to work. We got to find a way to do that. Oh, clear. No, that's not going to work. Where is it? $13 divided by 95. Nope, that's not working either. I'm going to have to delete all this. How did I get to that? I want to go, no. Alright, 13 divided by 95 equals 0.1368. So about 0.14. Well, that's our time. That's how long it's going to take to go 13 miles is 0.136 of an hour. So you need to multiply it times 60 to give it minutes. 8.2 minutes. So 8 minutes. Estimated time en route, 8 minutes. Okay, so we take off at 2100. We should arrive there at 2108. But we might not. Might be more of a tailwind, might be a greater tailwind. So we write down our actual time over this fix. So theoretically, we're supposed to get there at 21:06:08, but our actual in time en route might be different. Okay, so we'll play with that when we get along there. How much fuel are we using though? That's another question, right? So we know how long it's going to take. We know that it was 8 minutes. So fuel used, gallons per hour times the flight time. So 8 minutes. And we said the fuel burn was 10 gallons an hour. Let's see. And so we need to go fuel use, gallons per hour times flight time times 10 equals little about 1.5 gallons, 1.5 gallons. Remember that in order to get fuel, where's my red pen? That's okay, I'll just use this one here. Fuel used equals gallons per hour times flight time. So it's a pretty easy formula, pretty simple. 1.5 gallons. And you sort of think logically about it as well. I mean, that makes sense, right? You wouldn't burn 15 gallons in 8 minutes. We've almost got there. Oh yeah, I would write 10 in here just to give you to remind you of how much. I think we pretty much done all the information that we would want to get here. You know, we put the total, again, we put the total down here, 64 miles. We'd figure out the fuel for each one of these legs as well. Yeah, I mean, we're not complete, because we have to do each leg. A lot of this would stay the same, but all of that would stay the same. Compass heading, all this stuff here, all the way down would stay the same. This would change every leg, though, because now we're going 26 miles. I'm sorry, now we're going, 26 miles, and then we're going 24 miles. Each one would have to come up with a different time and route and fuel consumption. So I guess we probably ought to continue here. So here's our leg for, that's the time running, 26 mile leg. Okay, now we got 26 miles clear. So we take the, we want to know we're doing a ground speed of 95 divided by the, the distance was 26 divided by 95 is 0.28. 0.28 is about 30 minutes. Which would make sense. No, it wouldn't make sense. Hang on. Clear all this out. Clear this out. We've got, wonder what the flight time is, so we take the distance at 26 and divide it by the ground speed of 95. That equals 0.27 times 60. Oops, my calculator busted. Bad calculator. Divided by 95 equals, nope, no, the calculator is not working properly. Actually, it's operator error. Divided by 95, which is the ground speed, equals, and then 0.27368 times 60 minutes gives us 16 minutes. That's more like it. That would be more logical. 16 minutes. 25. Yeah, 25 miles. You're almost going 100 miles an hour, so that'd be 16 minutes. 16 minutes for that one, as long as we're on the same. Well, okay, let's keep going. 16. So for fuel used gallons per hour times flight time, so it's 16 minutes times the times 10. Three. Hang on a second. And 16 minutes. 16 divided by 60. 266. That's right. Times. That's flight time. Time 10 gallons per hour gives us 2.6 gallons. 2.6 gallons, which makes sense because again, twice as much. 1.5, 2.6, almost 3 gallons. Almost 3, which would be twice as much. Now we're going 24 miles. You sort of figure it's going to be pretty close, but we'll do it just for grins. We'll make sure we got it. 24. So flight time, we have distance is 24 miles divided by the ground speed, which was 95, and that gives you the decimal. Then you got to multiply times 60 to come up with minutes, and you get 15 minutes, which makes sense. 15 minutes. How much fuel are you going to burn? All right, and you got to go back to the decimal. Decimal times 10 equals 2.5 gallons. 2.5 gallons to get to our destination. So we add these up. 2.5, 2.5, that's 6.6. 6.6 gallons total. Well, we just add those numbers up to come up with the total amount of gas it's going to take to go from here to here. Less than it would take for you to drive from here to here. Okay, yeah, that's my sales pitch. We can also do that for miles as well. We could add all this up and it should come to 64, but I sort of did that before and we're 1 mile off. That's because of the inaccuracies of, you know, the way you laid it down. You sort of jump between numbers. Yeah, we can live with that as well. So you're flying along. Let's say you leave at 2100. You actually take off at 2100. At 2108, you look down hopefully and see that thing there. If you're not there yet, you got greater headwind. You need to start thinking about whether or not you're going to have enough fuel to get there. But obviously, 6.6 gallons. Your tank is 24-gallon tank. Probably 24 gallons in your tank. If it's full when you leave, great. If it wasn't full, which you may not want to be full. If you have a full load of passengers, a full load of fuel, you wouldn't be able to do it. So you'd have to use less fuel, make sure you have enough fuel to fly from here to here plus 45 minutes, or 30 minutes in the daytime, 45 at night. So how much fuel do you need? We know you're going to burn 6.6. How much fuel do you burn in 45 minutes? All right, back to the calculator. 45 minutes is 0.75. We know that. 75. The decimal of an hour, 75, that's 45 minutes. 45 minutes times the 10 gallons an hour. We need 7.5 gallons to fly for 45 minutes. So you take 6.6. 6.6, that's how much we'll use. And then we need 7.5 reserve. And hopefully we get 14.1 gallons. Yeah, because it's 1. Okay, so we need 14.1 gallons before we can actually take off on that flight. That's a minimum. And maybe since you're a student pilot and you might get lost, it might be a good idea to have a little bit extra. But if you got a full load of passengers, you know, you've got to do all the, we'll get into those charts later. Performance charts, because fuel weighs something and there is a weight limit of your aircraft. Hopefully this was enlightening and not confusing, but this is the typical way to do your flight plans. You'll need to do this, present it to your instructor. When you get around to the solo cross countries, you have to do this, present it to your instructor and say, here's my plan, and he's going to go through it. He's going to check them all because he doesn't want you to go off there and not make it. So anyway, hopefully this has been helpful.